Hey there, physics honors students. I'm going to show you today how to go about writing up the lab. All right. So first, in your course page, all right, over here, well, if I make it a little bigger, you'll be able to see it. Over here on the right, we have lab instructions, and we have a lab rubric. All right. So if you click those, they'll bring them up. All right. So lab instructions is a PDF file. You can try copy and pasting it, but it doesn't work good. You can try downloading it and opening it in Google Drive, I suppose, but I don't know. I really want you to retype it yourself so you get experience with writing up one of these labs. They're not long labs. What you see here is pretty much how long they end up being. Page and a half typically. Page and a half is probably about right, so you can do your drawing of the setup here. Here's the rubric, how the points are assigned. So a full lab write-up is worth 15 points. You can print this out and attach this to the front of your lab if you wish. I won't print these out, but if you want to see exactly points breakdown here, you can do that. I will just write it right on the lab myself. But the big points are the evaluation of data and the conclusion, written description of functions, and so on. So I'm going to show you how to kind of do this. I'm not going to do the whole lab. I'll describe parts of it on the example lab here. This is more for formatting, kind of talks you through the things. It's not a literal example, but I will show you how to write the evaluation of data and parts of the conclusion. Okay? So hopefully this will be a useful video for you to get you squared away on how to write up a basic physics lab. All right. So first things first. We did the evaluation of data a little bit at the end of class, but then I made a video last night, and it's found in the constant velocity motion topic, and it's right here, Kinematics Lab Evaluation of Data. So you should really watch this. I talked through the whole thing, kind of how we record the equations based on our graphs, and then how we evaluate them. So I really go through it here. But I'm going to fast forward in the video so I get to the point where the final equations are shown. So I'm just going to get to the end and pause it. All right? So let me just move this up a little bit so you can see it a little better. Okay, so you're going to start your Google Doc just like you see here. It'll be Physics H, your name, date of the write-up, whenever you're working at lab title. So this will be constant velocity motion lab. The purpose, all right, the purpose of this lab was to determine whether or not a student could walk at a constant velocity. And that was it. I talk about that in the video here. I write the purpose on the bottom of the whiteboard, one of the very first things. So put the purpose there. Now I would like you to copy this format. So one of the things I usually do is I make my margins smaller when I write up labs. You don't have to, but sometimes you can fit more on a page. Physics H, I'll just say Mr. Harmon. All right, and today's the 23rd, 9/23/2020. All right, title. Now, you really should be doing Times New Roman fonts on labs. That's kind of the standard for all science writing. And I'm going to center this next thing here. Lab title. I'll say constant velocity motion lab. All right. I usually like to make this bold and underline. So bold and underline. Then I'll go down to the purpose. I'll put it back on left justification. Still underlined. I usually don't underline the titles of the fields, but I do make them bold. So the purpose of this lab was to determine if a physics student can walk at a constant speed. Now, it's this predictive text that Google's doing nowadays. Walk at a constant velocity. I might add something there, using a position versus time graph, because that was the other thing. We really wanted to practice writing, making a position versus time graph. I usually drag the indentation over a little bit. I think you could just hit tab, but I like to leave a little bit of space. Materials. All right. I'm gonna not literally write everything here because it's gonna take too long. The evaluation data is the most important thing. So the materials, you list them out here. So we use the tape measure, cones, stopwatches, students, and then you record the data. You should draw the setup. Draw the setup. It can be from the top view, side view. So you'll actually you'll list the materials out. So list the materials, and then you will hit return a few times and leave yourself some space to draw it in. Make sure you leave yourself enough space. Or sorry, you're gonna do a separate lit apparatus drawing. So that's a little bit different. So leave yourself some space after the apparatus to write your procedure. So then you do the procedure. These are literally the number of steps we did, okay, in class. I'm not going to go through them now. You'll remember. You'll have to, if you're a full remote student, well, what we did was we set up cones, either 1 meter or 2 meter apart, depending on which class you were in. You can just say 1 meter apart. It depends what data set you're using, honestly. So set them off 1 meter or 2 meter apart, and then we had somebody walk. We walked along next to them and did the lap function on a stopwatch to figure out what time they got to each cone at. Then we made the graphs, the charts that you see that I posted in the topic. Then we graphed it in Logger Pro, and then we're done. Then we analyzed the data. All right, so now this is the important part, the evaluation of data. Now, in my one video over in the other topic, that's the Logger Pro topic, that video I showed you how to input data into Logger Pro. And I actually used one of our data sets. All right, I used one of the ones from the first section that had done it, and it went pretty well. So first thing we say is first describe your graphs using a sentence for each graph. So we only have one graph in this lab. And it was position versus time. You say something like the position versus time graph for the student walking shows a direct relationship between position and time. All right, so again, I'm going to indent this. I'm going to indent this row. Just this. Darn it. Okay, do it up here. All right. So direct relationship between position and time. Now, if you look here on the rubric, that's the first point. Experimental equations, meaning of slopes and y-intercepts, analysis of results. So you'd say now the graph, you'd say a fit line was applied to the graph, and the following experimental equation was produced. All right. Now, give yourself some space here. I usually hit return twice, then I put it on center justification, and I insert an equation. Now, this is going to take a little practice getting these equations down, and this is a good one to start off with. You do x equals 0.81. Now, we want to do meters per second. All right. So up here in the equation thing, we see some different options. These give you different options to put in here. Math operations is the one we use the most. So I'm going to do that. When you click that, it almost puts like in a little template there for A over B, right? And you can't really see the line, but it'll show up when we're done. The cursor's up top. I'm going to put in meters, M. Now, how do I get down below? You hit the right arrow on your keyboard, and it brings you down, believe it or not, meters per second. All right, then you hit the right arrow again, and it brings you to the end of this equation. All right, it's a little bit hard to see. There's no cursor, but it should be there. Meters per second times t. Some people like to put parentheses around the slopes. I usually don't. I usually just leave it like that. Minus 0.18 meters. So there's our position versus time equation. And then you have to analyze what the slope, oh boy, it shouldn't be equals, it should be minus. The wrong button there. Now you have to analyze the slope and y-intercept. I would say, just right now, the units, I'd say the slope, caps lock is on here, the slope of position versus time tells us the velocity, position, I should say actually, is defined as the velocity of the object. The y-intercept represents the initial position of the object. And we did that in our evaluation data. We talked about that. 41. I thought this was supposed to be 44. Correct. I got the wrong time. All right. Represents the initial position. I have an engineering 2 class coming in, but hopefully they'll enter quietly and I can just finish this up quick. So that was, hold on a second. All right, just back at it really quick here, try to finish up this video. So we wrote the sentence describing the relationship. We have the experimental equation. We have the meaning of the slope and y-intercept. Now you just have to analyze the results. The correlation on the fit line was, oh man, I don't have it here. Whatever it was like 0.9987 or something. Which tells us that the fit line was a good. Mr. Sorry. It was a good representation of the data. Sorry, I'm just trying to finish up physics 11 here. Correlation of fit line was 99, which tells us that the fit line was a good representation of the data, and that the student, I should say the linear fit line, and that the student walked at a constant velocity. All right. So then you have to do the conclusion.
For physics?
Yes.
Actually, our data was...
I'm not done yet. Give me like 1 minute. So the conclusion. This is the best video ever. The conclusion. First, restate your findings relative to the purpose or task. Recording a new derived general equation using variables instead of numbers. List any sources of error. List at least one improvement that could be made to the experiment. All right. Restate your findings. So you will say that, again, you basically just copy this last sentence here. Basically, you'd start by saying the student walked at a constant velocity. Since we had a linear, you'd probably say, since we had a linear relationship between position and time, the student walked at a constant velocity. The general equation for the graph is shown below. So we already defined what the slope and y-intercept were. So now we're just putting in the general equation. So yes, I know that's bold. Control B, get rid of that. We're going to insert another equation to make things look nice. Insert equation, and this one we'll put in the variables rather than the numbers. All right, so it'll simply be x equals vt plus x initial. So you can do subscripts here, right here. I'm going to do x and then over arrow, it'll bring me down, initial. You don't need to describe those again. We already described those. And then the last thing you have to do is come up with something. Now, generally, kids just kind of, make up something about how to think about the error. So our error here is this y-intercept, right? We should have started it at initial position of 0, but we have a little negative initial position. So it looks like the person started walking before the cone. So perhaps it started the time a little bit early. So you could make a future improvement here. Maybe use video analysis, whatever. So you come up with that part. All right? I'm going to leave it there. Hopefully that's enough to get you going. Got to get going in class here. Thanks a lot.